In this video, I'll talk about how to do the excavation work for group project number 1. The common question students always have is, Miss, how I should start? Okay, so the first thing you need to do is read the requirements for this group project number 1, right? You see, if you go through the requirements, I have a lot of assumptions, which other, extra information or additional information I give to you other than the set of the drawings and construction notes. And also on this, you see the requirements for the project, I also give you the recap as well. So those are the items you need to calculate, for quantities. So for example, excavation, right? We have 9 items you need to get the quantities for. You say excavation, basement, trench excavation, right? Excavate trench for grass step footings, then backfill or whatever. So after you go through these requirements, the next thing you need to do is open the drawings. In this case, we don't have a separate specification, but we do have construction notes with the drawings. I believe you're already familiar with this downcast project. So the first thing you need to do is read the construction notes first. Okay, you go through the construction notes and you highlight the information you need for excavation. For example, you say those, those notes, right? Which are highlighted, they are related to the excavation work. Also, you need to highlight the information you need. For example, here you see. Under construction notes, right? I read those notes and I highlight what's the size of the column footing, right? Foundation wall, what's the size of the foundation wall? What is the size of the foundation wall underneath what's the size of the foundation footing underneath of the foundation wall? And what is the thickness of the slab in the basement, right? That's number 7. You see number 7 here in the notes. Let's see number 7 there. See that, right? That's number 7 there. So that means this, this basement slab is 80 millimeter, the thickness of a concrete slab. And this 18, you say 18 is 100 millimeter concrete slab. If you look at the drawing, the first floor plan, you see this, note number 18. That means the thickness of the concrete slab in the garage is 100 millimeter. So that's the way how you read the construction notes, right? And also you put the notes. You can, highlight the information. Also, sometimes you can also transfer the information to the drawings. I would say, okay, under drawings, I'm going to write, right? For example, here, I'm going to write the thickness of the wall, right? I will say this thickness of wall here is 200 millimeter, right? I would put this information under drawings. So next time I don't need to go back to read my notes. Also, I would say, okay, I'll write down my footing size, right? 180 by 155, right? That's this footing. I can use different color as well, right? Here. Side and front. And here. You see, that's my footing, right? I want to say footing, right? I'll say foundation footing. footing is this. Oh, sorry. So if you read notes 14, right? You say notes 14. We have that's 14 here. We have, conquer curve. You see, we have a conquer curve sits on 350 by 150 concrete footing. That's this footing. So I can also write down here, right? This footing, right? This footing. I can also say that's footing, 350 by 150, right? So I know this footing is this size. So, that will remind me the size of the, column footings, foundation walls, right? Partition wall footings, column, this, foundation wall footings, column footings as well. If I want to know what is the size of this footing, I read the notes number 15, right? So after I, read the construction notes, now I'm going to look at my drawing, right? I should always start to look at my foundation plan first. So on the foundation plan, with all the dimensions are for foundation walls. Always remember that. Okay, so you should also be able to say, oh, that's a basement, right? There is a coat cellar at the front, and there is another unexcavated garage here. And we also need to know, unexcavated garage. That means you say remove the topsoil only. That means we are going to keep the soil inside of the garage. That also means we need to dig a trench along this wall. Okay, a big basement excavation, dig a big hole, for the basement, and for this wall, garage wall, we are going to excavate a trench. It's very similar like the example I gave to you in week 4. Okay, if you don't know how to do it, look at my example week 4. It will have very detailed explanation how we do the excavation in this kind of situation. So, of course, after we read this foundation plan, right? Goes through foundation plan. Then we need to go to the other first floor plan, second floor plan. We look at the elevation, right? When we look at the elevations for excavation, we pay more attention to the foundation, right? If you look at this elevation, you will see, oh, we have step footings here, right? 2 steps down. And what we also should be able to see the loads for step footing, that's notes, construction notes number 30. And we also should be able to see the dimension from the finished ground floor, right, to the top of the basement slab. So after we go through this elevation, right, we should go to the cross section as well. So on the cross section, we see the dimensions, right, for the foundation wall, the height of the foundation wall, and of course we can refer to the loads for the size of the foundation wall, size, and footing, right? Column footing size, partition wall footing size. We all, at this stage, we should know all the information related to them, right? So after read this, what you need to try to do is, in your mind, picture this, okay? Picture this in your mind in 3D. Okay, I give you some ideas about the 3D modeling to help you understand the 2D drawings. So, after understand the drawings, right, we try to visualize it in 3D. So we would say, okay, under foundation plan, we see the windows, right? we will say basement windows. That means when we make, when we build this foundation wall, we need to cut, recess, right? Make a recess under concrete foundation wall, right? You see, now you see this foundation wall along the garage, right? This is the garage. There is a foundation wall along the garage. See, this foundation wall is shorter than the basement foundation. See that, right? And also we can see we have partition wall footing, right? We have 3 column, column footings. We have grade beams there, right? So that means when we excavate the basement, the shape we are going to excavate is this, right? That's a big hole we need to dig. Then we dig a trench along here. And also we need to think about column footing pits as well. So this is how you can visualize in 3D, right? So after you understand this, now we are going to draw sketches to help to identify the shape of excavation and the size of the excavation. So now we are going to look at the drawing, right? Look at the 2D drawing. We are going to start to draw sketches to use the section drawing, okay? Cross section, use the section drawings to start the sketches. So the first thing we need to find out is where is the existing grade. You see, this is the final grade or finished grade, right? But we don't know where is the existing grade. And we also need to know what is the, condition, soil type or condition of the soil, right? The soil type, that's also what we need. So we are going to read the assumptions. Those are the extra information I gave to you. As you see, assume that existing grade is the same as the finished grade, the final grade, as shown on the drawings. And based on the soil report, we have good soil condition. And I also say there are low topsoil and site clearing needs. So for this specific project, we don't have topsoil. We also don't have any trees, grass on the site. So we don't need to do a site clearing. So that means we are going to start the excavation from we are going to start the basement excavation or trench excavation from the existing grade. I also tell you, when we backfill, right? We backfill with the excavated material, which is we backfill use soil, excavated soil to the finished grade. That means we are going to backfill up to the starting level of basement excavation. So which level we start excavation when we calculate the volume for backfill, we backfill to the same elevation, same level. That makes the calculation easier, right? If it's not in the real life, we need to do some adjustment. How to do the adjustment? You can refer to my I believe week 3 example. I show you how to do the adjustment. You still calculate, backfill to the elevation where you start the excavation, and then you say if you want to backfill higher or lower, right? You calculate that volume. Okay, that's what the adjustment you can do in the real life. So another thing is, construction methods we talk about in my example, right? I said, when we try to figure out how we excavate the basement to where, down to where we could excavate the basement down to the bottom of the foundation wall footing. We also can excavate the basement down to the bottom of the gravel, right? Basement gravel. So if you read the notes, number 7, notes number 7, you see, thickness of the slab is 80 millimeter, and the underneath there is a 100 millimeter crushed stone. So that's a gravel, right? That means the footing, you see, this footing size, this footing we know is 155, right? That's 155. And the gravel here. Yeah, if I draw that, sorry. If I draw that line, that would be around here, right? That's a gravel. That's the bottom of the gravel. And this dimension from there to there is 100. So the difference is 50 millimeter, right? 55 millimeter. So my assumption is, okay, let's excavate all the way to the bottom of the foundation wall footing. And we are going to make this thickness of the gravel from 100 millimeter to 155. That's my assumption. As a contractor, okay, in the real life, as a contractor, I'm going to decide this the way I'm going to do the excavation, right? I excavate the whole basement to the bottom of the footing. And when the gravel, the thickness of the gravel will be, I have to make the thickness of the gravel instead of 100 millimeter, now would be 155. That is my assumption. So if you look at the notes, this assumption here, you see 11. I said, assume there is a 155 millimeter thick crushed stone base under basement slab. Please replace 100 millimeter crushed stone with 155 millimeter crushed stone in the construction note 7. And we also say, assume there is a 100 millimeter crushed stone under the 100 millimeter thick garage concrete slab, because notes 18 didn't mention about what the thickness of the granular base underneath of the concrete slab in the garage. So I add this assumption. So those are the extra information you need to pay attention to. Just read them, you will realize that. Another assumption I say, pay attention to this. Assumption number 8, assume that the top of the garage slab is at the same level as the finished grade. That means the top of the garage slab is also at the same level with the existing grade. Okay, that's what you need to pay. You need to pay attention to. After we know all those information, now we are going to start draw sketches, right? You see, as I said, we are going to first look at the cross section to draw a sketch. So the first line we are going to draw is where is the existing grade, right? We know existing grade is the same as the finished grade. So this is the existing grade. See this line, that's the existing grade, right? I'll make it different color, maybe blue, right? That's the existing grade. So from the existing grade, I'm going to excavate to the bottom of the foundation wall footing. So based on this, I can do my calculation and figure out what is the depth of basement excavation. You see, I know here, you see, this dimension from here, you see, finished ground floor, right, to the top of the basement slab is 2470, right? To the existing grade, this dimension from there is 450. So I can take this dimension, I subtract 450, I get this dimension from there to there, right? After that, I need to add the thickness of the slab and add the thickness of the foundation wall footing. So that slab is 80 and foundation wall footing is 155. So I'm going to get the depth of my basement excavation, 2255. That's how I get it. So after I get this, I also know it's good soil, right? Good soil, we are going to cut a slope above 1.2 meters, which is 1200 millimeter. This slope would be 1-to-1 slope. So that means if I take this 2255, I subtract, you see, I subtract 1200 millimeter, I would be able to figure out the dimension for this slope, right? This dimension is 1055 because it's 1-to-1 slope. So this dimension here should be also 1055. If I want to draw that, right? I see. This dimension should be also 1055. Right? So based on this, I could figure out this dimension from the outside of the foundation wall to there is 1655. Why? Because the workspace, do you guys remember? The workspace here, from a foundation wall to the edge of the back, right? That's 600 millimeters, right? We know this. 600 millimeter plus 1055, we know this dimension here is 1655, right? So we can draw this, right? We also say here, you see, we have column footings here. That means after we excavate to the bottom of the foundation wall footing, and we need to dig extra column pits for those column footings, right? The depth of the column pits should be take the depth of the column footing, subtract 155. That will give us the depth of the column pits. Okay. Now, how many? We can see that from the, from the foundation plan, right? 3 of them. Of course, they have different dimensions. Okay. Pay attention to dimension of those 3 columns, or 3 column footings, I should say. Okay, after we finish this sketch, we are going to move this sketch to my foundation plan. You see, first, in my example, I told you, right, the easiest way to do the excavation is separate the volume of the basement excavation to 2 parts. The first part, we assume we are going to cut straight down, okay? Cut this, say this green, this color. We cut the, excavate basement from the existing grade straight down to the bottom, okay? Then we add the volume of this slope, which is a triangle. So if I want to draw this first part, cut it straight down on the ground, from the ground, right? From the existing grade, that's this here, you see. Here, right? Cut it straight down like this, right? The workspace, 600 millimeter, right? You see, that's here, that's this. You see, if I want to draw this here, right? This workspace here, right? That's 600 millimeter. This is 600 millimeter from there to there. On my foundation plan, That's this dimension here. That from there to there, 600 millimeter, right? From outside of the foundation wall, say from outside of the foundation wall to this edge, 600 millimeter, 600 millimeter, and 600 millimeter there, right? So I can draw this part. This is how it look like under section, okay, under cross section. This is how this part look at from there or under foundation plan. Understand that? So we also need to think about the workspace. 600 millimeter is a minimum requirement. Can be larger, but cannot be smaller. So if we have a situation like this here, we need to make sure we have this, workspace for, from here, this foundation wall to the edge of the excavation, right? The back of the excavation is 600 millimeter. Okay, make sure this is 600 millimeter. Of course, this part would be bigger than 600 millimeter. That's how much bigger or larger, 300 millimeter more. So that means this dimension, if we want to draw from here to there, right? That will be 900 millimeter. So pay attention to those kind of small things. When we excavate a big basement, right? We use equipment. We don't want to make those setback, right? We always cut it straight. So same situation apply to this side. You see this wall here has a, here there's a setback there, right? So we should base on this wall to decide what's the workspace. From this wall out 600 millimeter. So that's how we draw this first part of the excavation under foundation plan. And if we want to draw the, this slope, right, this triangle part, that's this color all the way around, okay? Make sure you imagine this in 3D, okay? That's all the way around. It's not only two, triangle, okay? That's what you need to, visualize it in your mind. It's a slope all the way around here. Okay, if we can draw this under foundation plan, now we can start to measure the quantities for basement excavation. Okay, let's look at the first part here. Okay, first part. We consider this slope is the second part. Okay, first part, let's cut it straight down to the bottom of foundation footing. So what would be the dimension for this? We want to get, the way we think is we want to get the area, area of this, right, based on the foundation plan. After we get the area, then we multiply by the depths. We should be able to get the volume for first part. So if we want to get the area, we need to figure out this dimension from here, right, to there, right? That's the dimension we need to figure out. We also need to figure out dimension from there to there, right? Say, if I change the color of this and make it different color. So this dimension, right? Take this dimension, I multiply by this dimension, I get an area of a big rectangle. Then I subtract this small setback, right? Small rectangle. I will be able to get the area of this part. That's the way how I think, right? After getting this area, I multiply by the depths, I get volume. So how we get this dimension? We have this dimension here, right? From outside of the foundation wall to outside of the foundation wall. Take that dimension, we plus 600 millimeter this side and 600 millimeter that side. We should be able to get this dimension, right? Same way, we can use the same way to calculate the dimension of this. Understand, right? Okay, that is the first part of basement excavation. Now we are going to look at the second part of the basement excavation. If I draw the dimension here as well, say if I draw this dimension here, I know this dimension 1055 at 1055, right? This is 600 millimeter. If I want to get the, area of this triangle, I would take base, right? 1055 multiplied by the height, 1055, divided by 2, right? I get a cross-sectional area of this slope, which is the cross-sectional area of this triangle. After I get the cross-sectional area of this triangle, which is the slope around, right? I multiply by the length. The length, we cannot see the length from the section drawing, but we should figure out the center line length of the on the foundation plan, right? When we talk about what is the length of the wall, we said looking at the center line, right? The center line length of that wall is the length of that wall. So same thing applied to this slope. The center line length of that slope is the length of that slope all the way around. So we are going to look at where is the center line of this triangle. So we know, okay, if you have an engineering background, you already know. I'm not sure you learned this in your high school or not, but just remember this. Okay, now the center of a triangle is, is from, I should say, gravity center of a triangle is from the base. Okay, from the base to this side, 1/3 of this dimension. Take the height divided by 3, right? From the base, 1/3 of this from the base. That is the center line of a triangle. Always this dimension from there to there, 1/3 of this dimension. This dimension there, center line, that's 1/3 of this dimension. So if we take 1055 divided by 3, that will give us 352. Okay, that's this dimension is 352. We add on top of 600 millimeter, that will give us 952, which is from outside of the foundation wall to the center of this triangle. 952. So if I want to draw this center line of this triangle, this slope on my foundation plan, it should look like this, right? It would look like this, the purple color, this line. If I can get the perimeter of this line, that is my length of this triangle, this slope all the way around my basement. So if you understand that, how I'm going to calculate the perimeter of this center line of this triangle. So what you can do is, I'm going to take this dimension, right? Same dimension. I need to add 950 this side, 950 this side. I should be able to figure out this dimension from there to there. Why it's 950? Because here, right, I gave this dimension. See, from outside of the foundation wall to the center of this triangle, right? If I draw this here, you see, I'm going to say from there to there, right? That's 952, right? That's 952. Understand that, right? That's this dimension here, right? So same thing all the way around this side from there to there, 952, from there to there, 952. So I can do this calculation. Same thing, I can get a dimension from there to there, right? Same thing. Take this dimension plus 952, 952 this side, right? After I get these two dimensions, I can take this dimension plus this dimension multiplied by 2. That would give me the perimeter, right? The perimeter is a length, okay? It's a length, 2D. the length, you need to think in this way. You stand there, it goes all the way around, right? That's a travel distance. You go back to the same point. Okay, after you get the length, you multiply by the cross section of this triangle, you get the volume. You add them together, you get the total volume of basement excavation, right? So I gave you a template. This is my template. I gave you the recap, right? You can use this recap and this template to do the calculation, right? You see, basement excavation, I'm going to calculate my first item, right? I copy this, I go to my standard worksheets, right? I paste this, basement excavation, I can start to lay out my calculation, right? How you lay out your calculation, you use this example I give to you. It's an Excel file in week 4. Okay, you go to week 4 and in D2L, you will be able to download this Excel file. And this is the way how you lay out your calculation in Excel. You can follow this, right? You see the drawing is slightly different, but the process should be same, okay? That's how you start, because quite a few students asked me about this. What do we need to do, right? That's how you start. Lay out your calculation, use the template I gave to you, and follow the example like this, okay? That's the first work item, basement excavation. Now we look at the second work item, right, in the recap. Excavate trench for the garage step footings. So that's this, right? That's this. The trench excavation. We would figure out what is the length of the trench. And I said, to simplify the calculation, we are going to use the length of the foundation wall as the length of this trench, okay? Just figure out the dimension from there to there. And then you multiply by, how after you get the length, you multiply by width of the trench, depth of the trench, right? So if you look at the elevation, you should figure out what is the depth of the trench. You see, from the existing grade to the bottom of the footing, minimum is 1220. We are going to use this 1220. That's the depth of our trench. So I'm going to assume I'm going to excavate the trench straight like this. We are going to ignore the step down footing, because when I excavate my basement, it's like this, right? Then if I calculate the trench excavation all the way to the foundation wall, right? Take the length of the foundation wall like this. I actually double calculate the volume of this part. This volume I double calculate can balance this volume here. That's why I don't need to consider the step down footing, extra excavation to this step down footing. So that's a common practice, how we do things. So now I know the depth of the trench, right? How we get the width of the trench. We know the workspace is 600 millimeter, right? You take the 600 millimeter plus the thickness of the foundation wall plus another workspace, 600 millimeter. You should get the width of the trench, right? Width of the trench multiplied by depth of the trench, then multiply by then you multiply by the length of the trench, you get a volume, right? That's this, item number 2. Item number 3, you see excavation for concrete slab and crushed stone base and garage. So what's that? Can you see? If we draw a section, okay, cross section, which is cut the section and cut the section like this, make a section, make a cross section from here to there, from the basement all the way to the garage, okay, like this. So what we need to pay attention to is, you see, the the top of the concrete slab is at the same elevation with the finished grade. That means the top of the concrete slab is same level with the existing grade. And we read the construction notes, we know in the garage, the thickness of the slab is 100 millimeter. Underneath, we have 100 millimeter granular base, right? To build this slab, we need to remove the soil from the existing grade down 200 millimeter. Understand that? To be able to build the, put the gravel in and then pour the concrete. So if you understand this, that means in the basement, in the garage, we need to excavate this, okay, cut this. Excavate from the existing grade 200 millimeter down. So that's this blue color. If we want to show this in our under foundation plan, that would be this part. Understand? See, this is the trench, right? When we dig the trench here. And when we excavate the basement, that's the slope, right? That's a slope up to there. So when we calculate area of this, this 200 millimeter thick soil we need to remove, that's this area. Okay, that's this area. So you can take the interior dimension, right? 5520, you subtract this dimension, this side, right? You can figure out that dimension, right? That dimension here, right? Based on this, plus the slope, right? This is not exact 600 millimeters, slightly bigger than 600 millimeter, right? Then you subtract 600 millimeter this side, you will get this dimension. Same thing, you can get this dimension, right? After you take this dimension, after you get this dimension and this dimension, multiply them together, you get the area of this rectangle, blue rectangle, right? After that, you multiply by the thickness of the soil you need to remove, which is 200 millimeter. You get a volume of this. That is your item number 3, okay? Number 4, excavate trench for garage grade beam. So if you look at the drawing, and even if we look at here, see this? The 3D drawing, we have grade beam in the garage, right? If we look at the 2D drawing, where is that? That's this, right? You see grade beam, cross section B, right? Section B. Grade beam details, that's a size. 75, it's a rebar, not the thickness of the slab. Thickness of the slab is 100 millimeter. So now I can draw a sketch to help me, right? You see, I know in the garage, we need to remove the soil, 200 millimeter soil, right? In the garage. And this is my garage slab here, right? If I remove 200 millimeter soil, it goes down to here, right? But my grade beam is there, right? I need to cut a small trench here. So the trench, if you don't think about the gravel, the trench would be this 200 millimeter by 100 millimeter, right? That's at least this. But if we do consider there are granular base underneath, 100 millimeter underneath, though the trench size would be 400 millimeter by 100 millimeter. That would be the size of the trench. Okay, if I draw that here, right? That's the length of the trench. Okay, if I draw it here, the length of the trench should be like this. Okay, that's the length of the trench. Understand that? Okay, if we don't consider, gravel, the size of the trench is this. If we consider gravel, the size of the trench is this. Okay, I remember in my lecture, in-person lecture, I didn't consider the gravel base. So I said, you can use this, trench size, use this. That's fine. But more, if you look at more accurate, right? We do have a gravel underneath. So the trench should be like this. That's the length. Okay. Lots of estimators, what they do, they will take this trench length, and multiply by simply instead in the real life, okay, the length, they would just simply take the length of this because it's a small item, okay. It's fine. Some of the estimators would took this cross-sectional area multiplied by this length. You get a reasonable number, but for this assignment and more accurately, you take this dimension, multiply by this dimension, you multiply by the length. Here, you get the 100% correct number. If you get this one, this dimension multiplied by 100 millimeter, follow the way I taught you in the lab class. That's fine, okay? I will mark both are right. If you consider gravel and if you not consider gravel, both are okay for this assignment. But a better way is you consider there's a gravel underneath, right? Okay, that is the number 4. Excavation for column pits. That should be easy to you guys, right? That's the say. We already talked about depths of the pits, right? Multiplied by this area of the column footing, right? Multiplied by the depth, you get volume. Remember 3 of them, right? Okay, and that's item number 5. Number 6, backfill around basement and the trench and garage. So you backfill excavated material to the basement and the trench. So when we calculate the backfill, the way we think about should be like this. Okay, you see. We, after we excavate a big basement, right, big hole underground, we are going to build this basement, right, and the foundation wall for the garage, right. After we build that, we are going to backfill. For basement, it's only backfill outside, right. For this wall, is backfill 2 sides. If we look at this part, okay, basement backfill, the easiest way for you to do the calculation, which is take the total volume of excavation, subtract the volume occupied by the basement. Okay, this pink color, you will be able to get the volume for backfill. I think that is the easiest way. Some students say, Miss, I want to do this. Take the volume of this part, right? Multiply by center line length of this. That's fine. But if you do that, pay attention to this here. You have extra backfill here, and you have a little bit extra backfill there. Okay, that's what you need to pay attention to. So for trench backfill, you take the total volume of the you see my total volume of the excavation, subtract the volume occupied by footing and foundation wall in the trench, you get the backfill, right? So what you need to pay more attention is here, you see here? If we consider, we backfill to the final grade, which is the existing grade, but we need to think about inside of a garage. We only backfill to the bottom of the gravel, which is to this level, and bottom of the gravel of this level. So if we calculate, backfill up to the existing grade, which we, we overestimate the volume, right? We need to take that volume. We need to do some adjustment, which we take the volume of, the total excavation, sorry, the total backfill volume to the existing grade to this level. Then we need to subtract the volume of this part and the volume of this part, only one side. So if I show this, okay, which you should do, okay, what I like you to do is not just look at my sketches. You try to draw your own sketch, okay? You say, if I highlight that, that should be this volume. I need to subtract, right? So you should be able to figure out the dimensions for this part. Where we get the dimension, when we do the excavation, we already know, right? The dimension for this part. That's what you need to subtract. Okay, that is number 6, backfill around the basement and trench at the garage. Now 7, backfill crushed stone under the concrete slab. So if I draw that backfill, if I highlight that, okay, if I draw a sketch, highlight this, underneath of the basement, right? Basement slab, I have crushed stone or gravel here. It's from inside of footing to inside of footing, right? For the garage, inside of garage, which is from the foundation wall to the foundation wall, right? That's what you need to pay attention to. So if I highlight this, that's what I say on the section drawing, right? If I want to show this on the foundation plan, that's this. You say inside of footing to inside of footing, right? So I can highlight this, you see this orange color, right? What I can do, I still can take this dimension, subtract the dimension here from outside of the wall to the inside of the footing, and I subtract that dimension here. I will be able to get my dimension from this point all the way to that point, right? I should get this dimension. Same thing, I do this. I get another dimension. Say this dimension, I have one there. There, I get this dimension. I also take this dimension and I subtract this dimension here, outside the foundation wall to the inside of footing, outside the foundation wall to inside of footing. I get this dimension, right? I multiply these 2 dimensions. I get the area of this big rectangle. Then I subtract this rectangle, subtract this rectangle. I will be able to get my area of this, right? Then I multiply by thickness of my granular base, 155, I get volume, right? After that, I need to think about if I have concrete column footings, foundation, partition wall footings, I don't have the gravel. So you need to subtract the volume of that then. Okay, so for the garage, gravel in the coat sealer, that's how it look like, right? In the garage. And what you do, you take this area of this, right? Inside of the wall to inside of the wall, you calculate area of this. You also need to think about subtract the grade B, volume occupied by the grade B. That's what you need to pay attention to. Okay. That is item number 7, 8. Weeping tile with crushed stone around the basement. We calculate the weeping tile by how many meters by length, right? So we look at the drawing. You see, weeping tile, we can figure out from there, weeping tile is right at the outside of the foundation wall footing. So we can figure out from center of the weeping tile to the outside of the footing is, half of 100 millimeter 50, right? Plus footing projection 140, we get 190. That is from outside of the foundation to the center of the weeping tile. So if we draw this center line of the weeping tile, So if we draw this under foundation plan, it would look like this, right? If we could draw this, now we can get this dimension, right? And this dimension, multiply them together, add them together, multiply by 2, we get a perimeter. Understand this, right? That's a length for the whipping time. That's the way how we should think. I have the help sketch on D12, so you can refer to that. So last work item is disposal of excavated material. So what you need to think about is the total volume of excavation, include basement excavation, trench excavation, extra excavation at the garage, right? The small trench for the grade beam, and excavation for footing pits. The total volume of excavation subtract the volume for backfill, which is use earth to excavate the earth to backfill. You take the total volume excavation, subtract, and total volume for backfill. You will be able to get the volume for disposal. So those are the surplus earth remain on the site you need to remove. Okay, that is this video about basement excavation.